I'm pretty confident in this thing's ability to move, but I'm a lot less so in its ability to fight wind at all. Alright, it appears to be working. I also have no idea this will even float. Alright, go. Look at that, it's moving. Okay, it's kind of going the wrong way. Go. Look at that. It's going. See if I can turn it. It is turning a little bit. Okay, I want to go this way. I want to come back. It's not coming back. That's not coming back. Okay. Alright. Yep. That's a problem. Let's see. There we go. See if we can go faster. Wait. Wait, it's going the other way now. See if it can turn. It's kind of turning. Ooh, not the reeds. Ooh. Ooh, it's coming back. That worked. Oh, this is amazing. Alright, come out. It looks like the water seal is holding up all right. A few modifications, and I might even be able to use that for the autonomous missions. Alright, I believe I have managed to reverse the direction, so the fin that steers should be in the back now. Okay, no, yeah, that does work. Go that way. Oh, that's amazing. Wait. Oh, the steering is better now, I think. Oh, that's perfect. Wow. Okay. Oh, the steering is inverted though. Okay. So I have to push one way to go the other way. That's acceptable. Should I try to fight the wind? Should we go out further? It's not super controllable, but it's controllable. It works a bit better at higher speeds. Yeah, returning the fin to its original position, the steering fin, jolts it a bit. Also, it appears to be just naturally turning in a certain direction. Precision was not used in the construction of this thing. I don't have access to my printer, so it was all with foam and stuff. The thing I used to mold the fin, the thing I set it on, was not flat and level, I guess. So one end of the fin is thicker than the other one. That, it's out there. Getting into the wind now. I want to try to send it all the way across. See that bit on the other end over there? I might try to send it. This is a bad idea. I know this is a bad idea. Because of the way it's set up, I didn't use the throttle on the remote control for, well, throttle. Because I needed to plug it into the Arduino, not the ESC, that also distributes power to everything. So it's actually the elevator controls. Oh god, it's gotten turned around out there. And so when I let go, it actually returns to the center and not nothing, which is kind of helpful because I can just sit here and it'll go. But is also kind of annoying. If I put it all the way down, it does still stop though. It doesn't seem to be making a lot of progress out there.
My goodness! No! Get back! Oh no! Oh dear! No! Stop! No! No!
Oh my.
No!
Okay, I can't actually tell which direction it's going in at this point. It might be coming back. Which way is it going? Oh, it's making some weird noises out there. I have no idea how much battery it consumes, or if the motors are gonna overheat, or if all the cables are good or what. The ESC should be able to handle it. It's 30 amps, so if it was a motor, it should be able to do it, because each one of these things uses less than an amp, and there's 6 of them. It's supposed to be supplying the current to move the thing forwards through the motor output, and it isn't. That's not a good noise. My controller just beeped. Oh, I've actually got a battery readout on the controller. It's used 1 bit. I mean, it's about halfway across, and I've used about half of the battery I want to use. You know what? I'm gonna keep trying to do it. I feel like I'm facing the other direction. I'm gonna try to turn around. The controller keeps beeping at me. What do you want? It's saying it's got battery, but it's making the no battery noise. Come to think of it, I also came out here to do a float test, so it's probably not good to have it out there. What are you gonna do? I mean, you'd not put it out there, but I'm gonna keep it out there. I think it's almost across. It's, I mean, kinda halfway. I'm not really good with RC stuff. I need to stop looking away from the thing I'm meant to be controlling. I can't really see it too good right here. I think it's more than halfway across though. Throttle level. Oh, there's a dog over there. Am I gonna have to fight a dog? Like the worm bot? Uh-oh, I think it's turned around again. No, it's not. I need to put something really visible on it to see which direction it's going. Okay, things I've learned I need to fix. I'm putting this here not even as a part of the video, as a reminder to myself. Fix the inverted, fix the fact that it goes backwards with its default settings. Actually, I might not fix that. I might just keep it plugged in the right way. Or the wrong way, I guess. Make it so I can tell which way it's going from far away. FPV camera! I was gonna put an FPV camera on it, and I was like, oh no, I don't need that. It's not gonna go very far away. Oh man, that would have been cool. I should have done that. It's gonna be really wobbly because this thing isn't super stable, but it's almost across now too. Look at that. When it's across, the wind should keep it in that little hole I'm trying to drive it into. This has taken a concerningly long amount of time to get across, but it is pretty much across now. So, and the wind wasn't a huge problem. I think the wind's mostly blowing horizontal to it, and the way its fin is, I guess that is gonna provide a lot of resistance to being pushed that way. There's something I didn't check. I didn't check if the servos were touching the water or not. I don't think they are. But if they are, that's a bit of a problem because they weren't meant to. They're not waterproof. And the spar they're placed on, I've got some shrink wrap around it, but not enough. So it's not quite waterproof either. It's maybe splash proof. Okay, I think that's a cross. I am going to go walk around the pond and try to get it. So believe it or not, this is actually a public park. So by the time I got over there, someone had moved the boat out of the water so they could use the spot with their dog. So I didn't really get to see how it was sitting or what parts of it got wet. So I lost a bit of the quote-unquote data from that because I didn't get to see exactly how it was when it got over there, but that's fine. So far, it looks like the pontoons are kinda sorta waterproof, which is good. I wasn't sure if they would be. Kinda sorta, yeah, by the looks of it. They're very unwaterproof foam that has just been shrink wrapped. So I don't know if that's gonna work or not. And the shrink wrap didn't even cover the whole thing, so it's like I shrink wrapped it with a bag from one end, then the other end, then the other end again. So it's not great, but it seems to be working all right. I fixed the steering, so it's no longer inverted. It turns out I actually had it already inverted on the remote because the plane I have been using needs it to be inverted. And now it turns the right way. Also, one of the spars for the fins had come undone either before or during that trip across the pond, so I've fixed that and it seems to go straighter now, so that's good. And there are a few benefits, like stuff can't get tangled in it quite like it will with propellers. It can't, like, I don't know, hurt animals as much. But also, it looks really funny. One of the main reasons I built this is because I thought it would look funny, and it indeed looks very funny. There it is out of the water, wiggling its little worm. There you go, that's the steering. You can throttle, and it goes faster. Slow down, and it stops and goes slower. Alright, I think that was a very successful test, and I will talk about the circuit right now. The circuit is pretty simple. It's mostly just the same as a regular RC plane, except instead of feeding the throttle into a motor, I feed the throttle into an Arduino. And then the Arduino takes the throttle signal and it gets a number from it using some random equation that I pretty much just messed with, adding random numbers until it gave me a number that worked well with the rest of the program to generate a sine wave to drive the fin. The fin servos are powered from the receiver. They take power straight from the receiver and then in each fin servo gets some. I don't know if this is the most efficient way of doing it or not, because the BEC ESC thing is meant to deliver high current out of its motor output, not the receiver. The receiver isn't meant to deliver that high of current, it's just meant to handle the servos of a normal RC model. So I don't know if this is efficient, I don't know if it's even safe, but it didn't catch on fire during that test, so that's a good sign, I think. So I'll talk about the code a little bit. It's mostly just kind of a horrendous mess of things I did until it did the thing I wanted it to do. It basically loops through all the servos, which start slightly offset from each other, and then adds the number I get from the throttle value equation. It just adds that to them each loop. So the higher the throttle, the higher the number, the more that gets added each loop, and that changes the frequency of the sine waves. You can plot the value of each motor on the serial plotter, and it makes a cool 5 sine waves, and you can see the effect of the throttle.